All right, guys. So if there's no questions over test, anything else, we're going to get back into finishing up chapter 4. This next thing we do. Question. When you use the calculator, for example, to find the roots of something, to find the zeros of a function, we're going to actually look at the base algorithm that it uses. A while back, I tried to request from TI any information about the actual algorithm they use, and it kind of makes sense. They said, well, no, we can't give that shit to you. You might be with HP or some competing calculator company. You want to see our good shit. I'm like, all right, whatever. So they use what we're going to talk about today, but they modify it a bit to take care of some spots where this has some issues. So the whole purpose of this next section, this Newton's method, is to discover the zeros of a function in some way. I like it. So, obviously the function is nice and factorable. We can find its zeros all day long. No problem. But not every function is easily factorable. So this to me, it's an application of derivatives in a way that you would never even think to do. Good old Newton did this because he had plenty of time to sit around under trees and shit, so why not? So here's the idea. 4.7 or 4.8? 4.8. As we talk about the method, you might be able to figure out what situations might make this freak out, and then we'll talk about those situations. Do they get into it? I don't know if they get into that. Yeah, okay. So here, this is, I know I say that sometimes, but this is really cool. So let's say we have this function, and let me give it some zeros here. Wow. All right. So I can see the 0 is right here, right? The x-intercept. And there's another one back there, but let's just focus on this guy. Doesn't really matter. We can do the whole thing we're going to do for this guy after we do this guy. It doesn't matter. So here's the idea. Let's say that let's give a scale here. 1, 2, 3, 4. So you can see like a good guess for this would be 3.1, 3.2. So we will. What we're going to do is we're going to discuss the idea. We're going to set up the algorithm that this uses. So we're going to develop it, and then we'll talk about, well, how do I get a good first guess? Because that's going to be what gets things started. You have to have a good, decent guess. I don't know if you guys remember, when you do the calculator to find a 0, it asks you for a left bound, a right bound, and then a guess. And if your bounds aren't good and your guess isn't good, it might freak this algorithm out. You want a decent first guess. You'll see why I've got to give it some walls to live in. So let's say our guess turns out to be right here. Now, for the sake of being able to see it from your chair, let me put it here. Put this guy to sleep. Oh, okay. So here's my guess. So here's what the actual value is at that guess, right? That's f of x1. That's obviously not 0. So I'm trying to figure out what this is. Now here's where the kick-ass cool shit comes in. I could get a tangent line to this point. Now let's see, what good would that do me? So if I get the tangent line to this point, maybe it's something like this. So I have a first guess. I can set up a tangent line based on that first guess. The tangent line's x-intercept is a second better guess. And then I do it again. So this is what's called a iterative process. You have something that gets you started and you keep doing the same thing to it. So I would take, this would be my second guess, x2. Has it gotten closer to the actual answer? Here's the actual answer, right? I'm trying to figure out where it goes across the x-axis. I'm trying to get the x-intercept. Has it gotten closer to it? Yes. You can imagine, again, almost always the answer to when will this fail is when I have this insane function just going up and down like crazy. This is, so it's, the process will love the shit out of it. It would hate this. Okay, maybe. We've seen that a few times already, where that throws things off. So then I do it again. I make another tangent line. Here's f of x2. I make a tangent line. Now I'm really, look at so every time I do this, I take a guess, I make a tangent line to the function using that guess. Get a second guess. Tangent line to the function using that guess. Get a third guess. Tangent line, blah, blah, blah. Every time I do this, you see how I'm getting closer and closer and closer. I like it. And obviously, if the function has any weird spots where the derivative is 0, for example, it's not that weird. What if my first guess would have been, let me make this guy definitely turn around. What if my first guess would have been like really bad? What if I would have guessed right here? That tangent line has no x-intercept. So the algorithm would go, it would have no idea. All right. So just like so many things we talk about in this class, being close is important. The idea of close. Right? And the freakier your function is, the closer you've got to be for things to work correctly. How are we guys? So that's the idea. I love you. You're always like, okay, that's great. That's the idea. What the shit? How do I do that shit? All right, let's talk about the doing. Here's the idea. What does this turn into in terms of a process? So let's look what we got. Let's back up to our first guess here. Here's x1. Here's f of x1. What's the slope of this tangent line? And you're all like, 7? No. How would I find the slope of that tangent line? What would I have to do to find the slope? This is obviously f of x's line I've drawn. There's the f. What would I do to figure out the slope at x1? How do I find the slope of any function anywhere? Yeah. So if I take the derivative, I'll get f prime. And if I evaluate it at x1, that's the slope of the tangent line. Okay, I like it. And then I just find, so what's the equation of that tangent line? We can do it. Do we have a slope? Yes. Do we have a point? Every now and again. Yes, we do. Write the equation of the tangent line. Go. Make that more like an M instead of a bird. There we go. All right, so there's two things going on here. It's at this point, the way you should feel about me asking you to find the tangent line of something should be, oh, good, this is awesome, it's an easy problem. I try not to say that too much, but at this point, if you don't feel that way about that kind of question, that's not a good place to be. Now, the second level of this is, I didn't give us any freaking numbers, but again, that's another thing where we shouldn't have a problem with working with an idea without any numbers. So this is the general idea of a tangent line. Throw in the information I've got. Okay. So again, going back to the process that Newton came up with, that I'm not saying you should kind of knew that this would work, but still, going back to the process he came up with, once I find that equation, the tangent line, what do I want to use that tangent line to do? What do I want to get from that tangent line? X-intercept of the tangent line. I love it. What is the x-intercept of that tangent line? What have we called it? You can't see, huh?
X2.
X2, I like it. So it's going to be x2, comma 0. Is that cool? Even more. Now, we got a number now, thank God. We got one number. We got 0. What are we doing right now? I am developing the algorithm that we will use. You're never going to have to do what we're doing right now. We're developing. Once we get to the end, we're like, we just do this shit every time for Newton's method. Okay, I like it. So what I'm going to do, I'm going to take this sucker and throw it in. And what is it that I want? I want x2. So once I throw that shit in, I'm going to solve for x2. Because that's what I'm looking for. That's my second guess, and it's better. Will it always be better? No. Right? Or if I just went a little bit away from this, look where this tangent line takes me. Did that get closer? Shit. No. So if my guess is too far off from what it's supposed to be, and how far is that? Well, it totally depends on how freaky the function is. This function isn't that freaky, but the minute I got this far away from the right answer, it just went to shit. Because the slope, we know the slope is changing as I get further away from a certain point. Okay, I like it. So, if we throw this stuff in, what goes here? Zero. And for x, I'm going to put x2. Now solve that for x2. Solve that for x2. What we're doing is we are finding the intercept of the tangent line to the function at our guess. That's matching up with the process. Let's see. Are you working? A little bit. So you can see I'm going to catch up to you guys. If I divide by this guy, and then add x1 over, right? Divide by this guy, and then add x1 over, I get x1 minus f of x1 divided by f prime of x1. So what is this problem going to supply me with? It's going to supply me with the function, and that's it. But what do I then have to supply it with? A guess. If it gives me the function, and it's got to be differentiable, and now you see why. If it gives me the function, I can evaluate it at my guess. I can take a derivative and evaluate that at my guess, and then I can subtract that from my guess. And it's really, one thing about mathematics is it's so easy to lose touch with why this works, but you saw why this works. This is computationally what we discussed here conceptually. So that would be the x-intercept of the tangent line, and as long as my first guess isn't that far away, this second point, that x2, should be better. And then I do it again. So what's x3 going to be? Can anybody, what's x3 going to be? I love that question because some of you guys are like, how the shit would I know? I don't even know what x1 and x2 are. Yes, you do. They're x1 and x2. What would x3 be? What do you think?
The answer to the x2 equation.
Yeah, so you just x2 minus f of x2 divided by f prime of x2. So let me try this. Let me write it the same way. Okay. It's always a question about which way they want to write. I'm going to take this away. We're going to do a specific example, obviously, in a minute. Take this away. So x4 would be x3s. x5 would be x4s. So what is x sub n plus 1? What I'm going to have in everything over there in that format, I'm going to have a bunch of xn's. I love it. So this is the real algorithm. The next guess is this guess minus all this shit with that guess. And I think the first problem we'll try, I'm going to do it step by step by step, and then I'm going to show you a little bit of a shortcut in the calculator that'll make these problems go a lot quicker. But the first time around, of course, I've got to be evil and make us all do every damn step. So let's try an example out. Let's see. Oh, what you got, Jeff? Let's do, I've got to go get some more markers, poor little markers. Yeah, I like it. Sure, we'll do this. Okay. Now, as you go through this process, I cannot walk around and make sure you do this, but you should not use the calculator at all at the beginning of this process. And we'll eventually get to a point, well, there's going to be a next level of this, but let's talk about what do I do with this shit. If that was x cubed minus 1, I wouldn't need Newton's help. In fact, I really don't need it here, but I'm just going to pretend like we do. If it was x cubed minus 1, then the intercept would be 1. This is x cubed minus 2. Is the intercept going to be more or less than 1? A little more than 1. Are you guys, does that make sense? Are you guys with me? So, because here, what's f of 1? What's f of 1? Negative 1. And what's f of 2? 6. So should our first guess be closer to 1 or closer to 2? If you get close to 2, it looks like the outputs are getting close to 6. What do I want my output to be, considering what we're trying to find? I want my output to be 0. I like it. Since this is differentiable, differentiable means it's continuous. If it's negative here and positive there, somewhere in between these two, it's got to be 0. So I want to have a guess closer to 1 because the output of 1 is closer to 0. Now, depending on how ugly my function is, that might not be the case. But here, I'm not going to make my first guess 1.5. You could, but let's be a little better. Let's make our first guess what? Because we know I should be a little closer to 1. So let's make our first guess 1.1. I love it. So let's make x1, our first guess, be 1.1. So how do I figure out what x2 is? What do I need? Well, let's just set it up. What would x2 be? x2 would be x1 minus f of x1 divided by f prime of x1. So, of course, what do I still need to do? Derivative, and then I can just throw stuff in. I love it. Then you can use the calculator. Now, I want you to realize this algorithm is not meant to be fully done by hand. The fact we're using the calculator and I'm saying, well, you can't just use it to find the root of this directly. You have to do this algorithm. We're actually analyzing the algorithm the calculator uses. It doesn't do frickin' magic. So it's about time, if we know enough math, we should be able to go, what the hell is that calculator actually doing, this little black box of magic shit? No, it's not. So what is f prime, obviously? I assume you guys just don't want to say it because it's too easy. So now I can figure out everything I need. So x2 is going to be 1.1 minus f of 1.1 divided by f prime of 1.1. F of prime. Do this up here. Oh no, where's my poor calculator? Oh shit. Oh well, I have to do the computer. Put you to sleep. F of 1.1? What's f of 1.1? I think it's 0.669. I don't know. 1.33. Negative, okay, thank you. So 1.1 minus, so I was right, what did I say? Negative, I already forgot what I said. 0.669, is that right?
Yeah.
Okay. And then what's f prime of 1.1? I think it's 3.63. Aha. Oh, what do you get now? Sorry.
It's 1.63.
1.63? Okay. I like it.
No, the denominator is 1.63.
Oh, it's 1.63.
Yeah.
Why would that be? Wait a minute.
Well, it's the derivative of the bottom, right?
It's f prime at 1.1, so just put a 1.1 in here. Right?
I made a mistake.
That's right.
Yeah. Right.
So what does all that come out to be? I think it's like 1.28.
Yeah, that's right.
Say again?
I got 1.28.
Holy shit. Come on. You gotta give me a little bit of props. It's my one skill. So 1.28, so blah, 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 blah. So here's the thing with this one. You really don't want to round much at all in these problems. So read me some more.
1.2842975.
Okay, good. I like it. That's going to be exciting. So this is a really nice function. We should have gotten a pretty good guess close to the right answer. So that should be a better guess. Now, I'll tell you what, hopefully already, let me make sure I set this thing up over here too early. There you go. That's what we just did. Now, let's go ahead and develop a little bit easier way to look at this stuff. Because can you see, if you had to do this multiple times, and you're having these disgusting answers. Okay, so let me show you, I'm going to show you in a couple different levels how to make this easier on yourself. Oh, thank you. You never do it satisfying. Boop. I don't need you. That's right. Don't have my calculator. So, I mean, one level of thing you can do. Does anybody know about one of the most important buttons on your calculator? The answer button. It's right above enter, I think it is. You guys see the A-N-S? Okay. So it's right above the negative button, is that right? Okay, I'll let you. Right above the negative button. This is the most immediate memory location ever. If you just did this and you have this on your screen, this number is in this memory location. So guess what you do? What am I supposed to do now with this? All the same shit we just did with 1.1, right? So guess what I'm going to do? Let's see if I can put this up here. Someday this will turn on. Here, come here. There's nothing to see there yet. So here's what we're going to do. This is just too nice to believe. The next thing I want to do is x3, and I want to use the answer that I just got. So instead of putting all this shit in everywhere, I'm just going to do this. And let's be a little more, well, I'll be a little more specific on the next step here. Somebody with me on that? Because that answer button has the last value I got, and the last value I got is the next guess. So what's it going to specifically look like then? Answer minus f of answer, that would be answer cubed minus 2. F prime of answer would be 3 times answer squared. That captures the model of Newton's method for this function. So let's see how this plays out. I don't care about speaker, go away. Please have the, oh, you do not have the, I love you. Well, that's your problem. All right, somebody, can I borrow your calculator? I have not brought mine with me. I think it's in my bag of all my calculators. Thank you, miss. Some computers have the emulator on them. This one does not. Too bad for Jeff. All right, so there's your answer button. So I'm going to redo this first stuff that we did. 1.1 minus, where am I at? 1.1 cubed minus 2. That's f of 1.1. Oh, you can't really see that. Oh, where's the lamp button? Lamp. There we go. That's 1.1 minus f of 1.1. divided by f prime of 1.1. And that's where we get the 1.28 blah, 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 blah. You guys, everybody's cool with that. Now, if I hit second negative, just to show you, answer has that number in it. The ANS always has the last number that showed up on your screen. That is stupid useful. So useful. So what I'm going to do now, I'm going to say answer minus answer cubed minus 2. So I'm doing the answer minus f answer divided by f prime answer. So divided by 3 times answer squared. And then we're going to get our, what is this going to give me if I do this? Semi-specifically. I love it. You guys are like, I have no flipping clue. Not numerically. What's the idea behind what I'm going to get? What is it I'm calculating right now? X3. The next better guess. Again, it's better if my guess was decently close based on how bad the function is. Right? Each time it should get better, better, better. So let's see what we get now. Now here's the, so that should be a little bit better. Now here's the ultimate cool shit. If you ever do something and you hit enter and then you hit enter again, it recalculates what you had plugged in. If I hit enter right now, it's going to recalculate this. But what does this have in it now? This! So do you see, the whole idea of this process is you keep doing the same thing over and over and over and over. Right? The next thing we have to talk about is when do you know when to stop? That's the next thing, but we're not there yet. Right? Although I'm 58 years old. Right. Let's not do it. So if I just keep hitting enter, it's going to recalculate the last thing I put in there, but every time it does, it makes the next guess. You guys get that? Iterative processes, the calculator eats it up. Enter, 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 enter. What do you notice it's happening? Enter. Is it changing anymore? Enter. No, it's not changing anymore. So I have found the answer correct to that many decimal places, at least. Right? The calculator won't show me more. Are you guys semi with me? So when do I stop? We're going to do a little bit more disgusting function, so it might take some more time to get there. And the question would say, be correct to the 4 decimal places. So when do you stop? When those 4 decimal places stop changing. The rest of it might change, but you stop when those 4 stop changing. So let me kind of do this over again. 1.1. I'm sorry, Cassandra, you just got to watch. So if I do this again, now watch. If I do it again, do you see how it changed right there in the second place? So the instructions say, be correct to the first 4 places. I can't stop yet. I can't stop yet. There were still changes in the first 4. There, look, the first 4 don't change anymore. And to be honest, this function's so nice, I would stop there anyway, because the next thing still doesn't change. Can somebody tell me how do I get the exact answer to that? You can solve this stupid thing by hand, right? I don't want the real answer. There are 2 complex answers. I don't care about those. Thank God. What's the correct answer? What's the x-intercept? How do you solve x cubed minus 2 equals 0? Set equal to 0. Add 2. Take the cube root. So what's the right answer? Cube root of 2. What's the cube root of 2? So the process we just did. Yes. So for this function was easy. We could have done it by hand from the beginning, plugged a damn thing in the calculator like we just did. So why did I start with this one? For that reason. I can see what the answer is supposed to be, compare it to what my algorithm did, and go, oh shit, it's the same, kick ass. So then we know the algorithm seems to work. It's built on theory, and experimentally it worked. big checks, yes.
Would that work for all equations that you get, or just some?
So there are problems when, for example, oh shit, you guys missed all that on the calculator, so we'll do another one. Obviously there are problems related to the guess being either too far away or, let's say I have something like this. So this is the right answer, and my guess is this. The tangent line goes crazy. Is this very far away? Maybe not. Maybe this is 0.9 and this is 0.91, right? There are functions that will do that. So I'm like, that's not very far away, but the tangent line has a zero slope. It's never going to give me the next guess. So look at what's going to happen here. What's f prime at my guess? What's f prime? 0. So this whole thing's going to go to shit. Divide by 0, you make a black hole. Some other civilization will take a picture of it and say, there used to be people there. So don't do that. Sorry. So there. One thing is if your guess is too far away, but what governs what too far away is? Well, one thing is if the function is really freaky. Another thing is if there seems to be a flat point somewhere, you don't want to be anywhere near that. So if this is what the function kind of looks like, I know I'm going to want my guess to be, I got to make it much closer. But then it gets to be a question about, well, how do I really make a good guess? Well, I'm not going to give you functions that are quite this freaky, because this is a really tight turn there. Okay. The other place where this has problems is something like this. It might have, well, let's see, is it this algorithm that has a problem with this? Oh, this one will be fine, I think. So if I take a guess, the tangent line is going to get me closer. Take a guess is going to get me closer. Yeah, that's fine. That's fine. This is a different algorithm that has a problem with this. There was one other situation where there's a problem. I can't remember. All right. Let's try this with a little more interesting function. Let's do... Yeah, let's do this one. This looks really gross. So find the roots of this. So there's a few different ways to get a good guess for this. So what I'm trying to do is I'm trying to solve this equation, right? Try to solve that equation. That's the whole purpose of this, right? To find the x-intercepts. So one way to do it is just to blindly try numbers out like we did a minute ago. So if I do f of 1 and I do f of 2 and the sign changes, that must mean there's a 0 between those two because this is a continuous function on its domain. Obviously, what x value can I not use? What x value can I not use? 0. Okay, so I want to stay away from that bad boy. So, I mean, I could just start, flailing around a little bit. I mean, if I plug a 1 in, just to try something, what do I get? What's f of 1? 2. Yeah, 2 minus 1 plus 1, it's 2. What's f of 2? Negative 2, okay. See, now, but you should have a big problem with what we just, we got one of the roots, right? One of the roots has got to be between 1 and 2. Because it's not near 0. And It is continuous on its domain, and we just got a sign change, so it must go through the x-axis. I know there's a root between those two. But depending on the function, 1 and 2 ain't always going to work. Maybe it's 11 and 12. And are you going to guess that right away? No. So let me give you a little bit different way to get a guess. Can I write this like this? You just did, Jeff. Oh, yeah, I did. Can I graph both sides of that? Give a rough sketch. Let's see. So 1 minus x squared. Can anybody tell me anything about this guy? If I graph both sides, a rough sketch, what am I going to look for between those two things? Where they meet. Right? I don't need a perfect sketch. I need a rough sketch, but not crazy rough. Not like... So anybody tell me anything about this? Anything? Downward, parabola, shifted up. 1. I like it. So there, x-intercept's even. And then shwa, shwa. So that's this side. Anybody tell me anything about this side? What does something over x look like? What does mine say? Sweet. What does 1 over x look like? You guys should know. Nope. Oh, it's more like absolute value, right? All right, all right. It is the most basic hyperbola. There's nothing about the function that's in the hyperbolic form. Are you with me? But this is a remarkably basic hyperbola. It looks like that. So I know the shape of it. So just look, even with this not good enough rough sketch, I can see there's going to be a few places where they meet, right? At least one. So let's be a little more precise. 2 over x. At 1, where is 2 over x? 2. And then it goes like this. So screw that side of it, right? You guys semi with me? I mean, at 2, where would it be? 1. 2 over 2 is 1. So, and at 1/2, it's going to be at 4. They're not going to meet over there. Are you guys with me? I can forget about that whole part. This approach is going to be the only approach that will work for some problems. And I know that some of us don't like graphing. But that's too damn bad. So I might, on the next quiz, have a part of the quiz where you can't use a calculator or something. I just need some guarantee that you're not just... So what about back here? I know it's going to live back down here somewhere, right? So again, I can do what at -1 it would be -2. At -2 it's going to be -1. So it looks like it meets somewhere right there. So what looks to be a decent guess? I knew. What did I know here? What did I do? That doesn't match up with what we did here. That sucks a lot. Let me see. These two approaches should agree. So what did I do? Let me see. 3 + 1, 2.